So for those of you that weren't here before, my name is Perry Krug. I'm a senior solutions architect with Couchbase. I've been with the company about 3 years and have been working quite a bit in Israel with our partners and customers here. So sizing of Couchbase, thank you, is going to be directly related to the performance that you get out of it. We've made a number of improvements over the years where it's not quite as critical to overall stability. We used to have some problems with that years ago, but now it's really about the performance that you need to get and that you're going to get. So the kind of the high level considerations are you want to be serving as many of your reads as possible out of RAM. That's going to give you not only the lowest latency and the highest throughput, but the most consistent latency as you do much higher operations. You want enough I/O, both network and disk I/O, to handle the write traffic that you're doing. We'll look into those in much more depth. Couchbase is an in-memory or has an in-memory caching layer, but we also, for persistence and other reasons, need to be able to get data to disk, and so your writes eventually need to be able to be written to disk. We'll talk about that much more in a minute. And then mitigating the inevitable failures, making sure you have enough nodes and that your data is distributed evenly across those. So this is a graphical representation of what we mean by scaling out. Taking all of the load from 3 or many more application servers, the load coming out of that tier may be quite high, but it's being distributed across as many Couchbase nodes as you have, which means each one at the disk and at the network is actually only needing to handle a smaller amount of load. And this is kind of the quintessential thought process behind scaling out, is distributing the workload, distributing the data across as many nodes as you can so that each one has to do less and less work. Yes? Yeah, so the distribution logic that we use is as even and as essentially random as possible. We use a CRC32 hash on the key name that you are supplying to determine which of 1,024 shards that key belongs to, and those shards are evenly distributed across the servers themselves. And so what that leads to is two things. One is very, very even distribution of data, regardless of what you've chosen as your document naming or key naming convention. So in production and all of our testing, you see very, very even distribution of the items, the keys, and also the workload to those. The other thing that means is you never have to re-shard. You never have to pick a new shard key like you do with Mongo. You never have to rebalance or rehash the data into the different shards. And it works very, very well for that even distribution. Does that answer your question? Okay. So when we talk about sizing, and I talk about sizing a lot, there are basically 5 factors. And these 5 factors are what are going to answer the question of how many nodes do I need. And these 5 factors in relative order are RAM, disk, CPU, network, and data distribution or data safety. And we're going to look at each one of these in more depth through the course of the presentation, but one of these is going to dictate how many nodes you need. If after your sizing review and sizing calculation, the amount of RAM is saying you need a certain number of nodes, that's going to be the number of nodes that you need, even if all of the other factors say you need a less number. Or if the amount of disk throughput that you need dictates that you need a larger amount of nodes, that becomes your determining factor, your determining sizing factor. And so regardless of everything else, you need enough nodes to meet the highest of one of these factors. So let's start off with RAM. I talked about a little bit in the earlier presentation. You want to have enough RAM to keep your working set in RAM. Let me skip to this and then come back. Your working set really depends on the application. It is a percentage of your overall data set that you need to have cached in RAM for the lowest latency and highest throughput access. Couchbase will automatically manage this for you as you fill up RAM, but you're going to need to plan to size your application, size your Couchbase cluster to have enough RAM to hold whatever your working set is. So if we take an example of a social game, that may have hundreds of millions of users in it, but only a few of those are active at any one point in time, your working set is actually a very small percentage of your overall data set. This means you're going to have much more data on disk than you do RAM, or you do have data in RAM. You need a much smaller proportion. Another example is maybe a social media application or a more traditional business application where you need a larger percentage but still not all of the data. And then on the farther extreme, many and almost most of our ad targeting customers, ad networks, want to have their entire data set cached in RAM. And so even though the entire data set is also persisted on disk, they have enough RAM and have sized enough so that the entire data set is cached in RAM. And that's what we talk about working set. So if I come back here, the total amount of RAM that you need in your cluster is going to be determined by the working set, the amount of metadata that you need to track all of your data, and being sure to keep in mind the actives and replica are both kept in RAM, so that if you do have a failure, your data, your replica data, is still cached in RAM, as opposed to having to be read from disk for all of that. This metadata in the current version, and even the soon-to-be released next version, Couchbase stores its entire metadata in RAM at all times, our primary hash table. And this provides us very, very, very fast lookups, especially for data that does not exist. So our miss speed is just as fast as giving you the data if it did exist. This does introduce some limitation when you start to talk about billions and hundreds of billions of items. That leads to quite a bit of RAM that's required. One of the major features coming in 3.0 later this year is the ability to remove metadata from RAM as well as the data itself. So that will make Couchbase a much more good solution for when you have huge amounts of data, but only really need a little bit of it cached in RAM. And then the last thing that tends to lead to RAM sizing, when you start to talk about views and indexes, we've found a pretty big benefit from providing some amount of file system overhead and file system cache to cache the views, their B trees, some of their indexes, so that multiple reads to the same view can actually be served from the Linux or Windows file system buffer as opposed to directly from hitting disk. At this time, we don't explicitly cache these views in RAM. That's something we're looking at for future enhancements. But leaving yourself sometimes a significant amount of RAM outside of just your cache quota can lead to much increased throughput and lower latency for those view requests. It's a little hard to quantify because it depends on how large those views are, how fast they're changing, what other churn is going on at the disk level. But we have some internal benchmarks that definitely show an impact from that. The next second most and sometimes more important factor is the disk I/O and to some degree disk space. As I mentioned, Couchbase, the writes that you perform to Couchbase eventually need to get down to disk for both index processing, cross-data center replication, overall persistence and reliability of the data. You want it to be persistent to disk. And so the kinds of things that contribute to our overall disk I/O usage are your application's sustained write rate, keeping in mind that replicas are also an extra multitude of writes, the ability or the need to do rebalances, the ability and need to take backups, and then if you're doing any cross-data center replication or views and indexes, and the need to do compaction. So all of these factors use disk I/O and all compete for disk I/O within your overall system. And so taking all of this into account, leaving yourself enough buffer or enough disk I/O, either through the use of many more nodes or just more nodes, or the use of SSDs is important. Disk space, usually not a big concern. In Amazon, where you can actually choose the amount of space that you want to use on disk, you want to make sure not to give it too little. You don't ever want to run out of disk space. But the kind of things that contribute to disk space, compaction, in combination with our append-only disk format. So if you saw the presentation earlier where we are updating and writing to disk, the disk space is constantly growing until we do a compaction to shrink it back down. You want to make sure you have enough disk space for that maximum peak of disk space, and keeping in mind that both the actives, the replicas, and your indexes are taking up space on disk. Some more details about disk I/O specifically. Our disk writes are buffered, so your write goes into RAM first. There's a queue that can grow and will eventually be persisted to disk. We see lots of applications, lots of workloads that have a growing disk write queue over the course of their day through the peak of their day, and then as that workload subsides from their application, the disk write queue drains back down again. And this is a perfectly normal and well-expected usage and behavior of Couchbase, and actually is an advantage and leads to best performance to your application, because you don't have to wait for every single write to be persisted to disk before you can move on. It's always replicated RAM to RAM, but waiting to disk is going to slow things down considerably. So keeping an application moving at the speed and the interactivity that it needs to is an important part of running Couchbase. And so allowing the disk queue to grow and shrink over time is a benefit and a normal behavior. Making sure that it doesn't grow forever and that over time it doesn't get higher and higher is what we're talking about sizing, and making sure you have enough disk I/O over the course of time to get that data drained to disk eventually. Yeah, that's just some more details. I don't need to read through each one. The overall throughput, as I mentioned, is a combination of all of these things. I mentioned read here because if you're not reading from RAM, you're reading from disk, which means that's also contributing to and competing for your disk I/O. And we'll see it later on. Some of these things are easier or harder to understand the effect of. We use our disk write queue as a proxy or as a general metric for whether you have enough disk I/O or not. If you ignore the compaction and the cross data center and the indexes and the backups, you will see the lack of disk I/O in the disk write queue. Your writes to disk are the most important thing to get to disk. And if they are unable to get to disk for whatever reason, that's where you're going to want to take action. And that's very easily visible. It's a single metric to watch and be aware of over the lifetime of your application. The next couple sizing parameters are usually less important, although for certain workloads, certain deployments, they become more important. The first one being CPU. In general, most of our deployments have enough CPU capability, although if you're looking at deploying with 2 or 4 cores, you're right about at the minimum of what we would recommend, and for doing certain things, for putting more load on it, you're going to want to have more cores. Your in and out of RAM performance, your latency for reads and writes out of RAM is not going to be affected by CPU at all. If that's all you're doing, you're going to see very, very, very low CPU usage. All of our CPU usage comes from interacting with the disk, whether it's writing data down from your incoming workload, whether it's doing a rebalance or a compaction or views or cross data center. That's where all of our CPU load comes from, and so that's what you want to make sure you have enough CPU for. If you're not doing any of those things, you can get away with much lower CPU resources in your cluster and your nodes. Network sizing, also very rarely important. If you start to think about pushing 150,000 operations per second, 200,000 operations per second, then network sizing comes into discussion. You want to make sure you have enough bandwidth, that you have the lowest latency across your network. But really anything lower than that, you're not maxing out a single gig E network, and you're not really going to notice the effect of a network. But for any good production deployment, it's a good thing to keep in mind. And so your write traffic, your read traffic, your writes are then duplicated 1, 2, or 3 times for replications. So that adds traffic on the network, rebalancing, and cross data center replication. All kind of combine to use the network. and if you don't have enough capacity, you're going to notice some suffering there. Again, it's number 4 because it's usually not very important, but it's not something you want to just forget entirely. I already talked about this. Make sure you really want Couchbase is best benefited by the lowest latency, highest throughput links, not only between nodes, but also between clients and the nodes. We do have some customers that deploy across a firewall, and they get higher latencies. They know they're going to get higher latencies. That's a factor of their application. If you want the lowest latencies possible, you need to cut out as much in between your clients and your servers as possible. On a single gig E network, the best latency we've seen is about 400, 500 microseconds. On a 10 gig network, the best latency I've seen is about 80 or 90 microseconds. Same thing with InfiniBand. So depending on what your application needs, that's what you should be targeting. And if you're not getting that, if you're getting 2 milliseconds, 3 milliseconds, unless you're in Amazon, there's something else wrong. There's something in the network bottlenecking or something within the application. You should have a very good understanding and expectation of the latency that you're going to get from Couchbase, because we know that coming out of RAM, it's so fast, and the network is what's causing all of any additional bottleneck or overhead on that. So the last one, number 5, for factors controlling your sizing, the general data distribution, general data safety. Everybody understands that one node would be a single point of failure, and they don't want to deploy with that. Many customers starting out think that 2 nodes is sufficient. I have replication. Why would I need more than that? Well, the reason really we recommend at least 3 nodes in production is so that if one fails, you don't have a single point of failure. If you need to remove one node to do an upgrade, to do some maintenance on it, you don't have a single point of failure, and the data can still be replicated within those 2 nodes while you do whatever you need to do on the 3rd. In addition to the benefit of having the data and the workload distributed, in addition to the fact that most of our customers need more than 3 nodes anyway, if all other factors are minimal and you have a very small data set with a relatively low write workload, all of it can be cached in RAM even on a single node, I'd still recommend going with 3. And that will give you the safety and the high availability and the reliability that you need. Also, hopefully, all of our applications are going to scale well beyond our wildest dreams, and you want to be able to add a 4th node and a 5th node and a 6th node, which is easier when you start with 3 than when you just start with 2. Yes, you had a question? So the question was, with more nodes, is there a decrease in performance of bulk operations? And the answer is no. There's no difference in performance from working on 1 node versus 100 nodes. And that has to do... It really doesn't, because your application, your client knows which nodes to send those requests to, and it's only sending the keys to the nodes that are asking for that, and the response is coming back directly from those nodes. And in fact, for those requests, you're getting better performance by having it spread across multiple nodes, because if you say ask for 1,000 keys from 1 node or 1,000 keys from 10 nodes, each one only has to do 100 keys as opposed to 1 node doing 1,000. So it actually is benefited, and you won't notice any difference from doing that within a production environment. Okay, so any other questions on these kind of 5 factors? And we're going to use this throughout the rest of the presentation. You'll see me talk about this, and this is kind of what, when we size a Couchbase cluster, these are what the 5 factors we talk about. Yes? That it is providing. Again, within Couchbase, looking at the cache miss ratio and the resident item ratio for indications of your RAM sizing, looking at the disk write queue. As I mentioned before, that's kind of our general proxy for whether you have enough disk throughput or not. If that queue is constantly growing or is unable to drain over the course of time, that means that all the other things are contending for disk I/O, and you really don't have enough just to get your data down to disk. Means that you're going to want to do something to improve that. And just making sure that you have enough space, that you're not running out of disk space at the disk. And lastly, monitoring the cross data center replication, your indexing, the fact that compaction is happening appropriately. All of those things are indications of a properly sized and well-functioning Couchbase system. As an example of a customer, this is a much older version of the software even. This one actually comes from an Israeli customer. I'm not going to announce the name. It's not Viber. But you see the disk write queue growing here up to about 300,000 operations per second. I think this is across 20 nodes of the cluster. But what you see appropriately is that it goes back down again every day. And there's a little spike on Friday night or Saturday night, but it's able to drain back down again. And this is an indication of a well-sized system because over time, you have the disk queue draining down to almost or at zero. And this, the size of this is going to be a little bit of your own comfortability with the number of items waiting to be written to disk at any point in time. But while this is all going on, you see there's a very, very low cache miss ratio. You see the writes per second, 14,500 per second going up and down. Throughout that whole time, those writes are all receiving sub-millisecond latency because we're queuing them in RAM. And that allows the system, the application, to continue working without slowing down just because the workload of the application is increasing. So quickly, as I'm wrapping up here, I've mentioned before, Couchbase is a share nothing and almost linearly, almost everything scales linearly. So adding more nodes it will get you more RAM and more disk I/O. We always, especially from a sizing perspective, recommend adding more nodes before you need to, and adding more nodes instead of incrementally increasing the size of a smaller cluster. We talked earlier about scaling out to a certain point and then increasing the size of all of those nodes and being able to scale back in. That's certainly something that our customers do. But your first approach should not be just increasing the capacity within a smaller cluster. You want to be adding more nodes and doing it before you need to so that you can spend the resources to do a rebalance, then grow into that increased capacity without having to get out of some problem scenario. Sizing is somewhat of a tricky kind of use case application specific. We offer our services both here in Israel online to help you understand the parameters and the requirements of your application, your hardware, your environment. And really the best recommendation that we can give is to constantly monitor what you have in production and match that back to what you think you should be sized for. Okay, so the last couple slides to dive in and get started. You want to really understand the amount of items that you have, the size of those, and then your read, write, and delete ratios. Check back for our documentation and our formulas. They are evolving over time as we learn more and more about different environments and how things are sized appropriately. Different versions of Couchbase change the sizing requirements as we make better use of disk I/O, as we shrink the metadata in RAM. All of those things change the formulas of ours, and then always test this out, put it into production, and then monitor for a circular feedback. Lastly, our documentation has all of this and more, and I wrote a pretty nice long sizing blog that will talk about some of the hardware recommendations, some of the scaling recommendations. This presentation in much more depth is covered in that, and you shouldn't have any problem finding it online. So with that, and I still have a couple minutes, I don't have any more minutes, thank you very much, and I'll take a few questions.